Good afternoon, or maybe in my case, good evening. My best regards from Rome. I am Riccardo Valentini, and I'm sorry not to be there with you attending your fantastic conference. Anyway, I would like to give you a small talk about a new approach for monitoring ecosystem services, with particular applications for green infrastructure and trees in urban environment. How many trees there are in the world? This is a rather simple but very crazy question. So today we know the answer. There are 3 trillion of trees in the world. And you can ask how we know that. And that's incredible because we have been able to count trees from satellites. So we have been able to pinpoint each tree in the surface of the planet. And also thanks to citizens, this data has been validated. And so we know the answer. So this is just an example for telling you that we can do many things today that were not possible 10 years ago. This big revolution in technological capabilities is given by the example of the Internet of Things. As you can see today, there are many areas where sensors are distributed in big networks, and data are arriving to the web, to servers and clouds, and artificial intelligence is taking this data to produce meaningful information. But most of this is actually, all of this is really related to industry. You can see the icons in this emblem of the Internet of Things are always dedicated to something like appliances or transport or cars and so on and so forth. There's nothing that really recalls the nature of the environment, and this is really now the time to move on from the Internet of Things applications to something that is the monitoring of nature and ecosystem services. Probably aware of the fourth industrial revolution, a big transformation which the industry has been going through from the 18th century up to now, and we are now in the fourth phase of this transformation of industry, where cybernetic, artificial intelligence, Internet of Things is applied to production systems, so automotive, robotics, and so on and so forth. I like to use this paradigm to also illustrate the importance of what I call the Nature 4.0. 4.0 is something analog. Using the Internet of Things, using the capabilities in monitoring and sensing the environment at all levels, from the plants monitoring to wildlife monitoring, to air quality, water quality, soils. And this is possible to do it today using this data streaming to cloud, to internet, and so it's possible to introduce artificial intelligence tools like machine learning, deep learning, big data analytics, to extract meaningful signal that help us to understand how ecosystem works, how they're performing the services, to monitor their status, their health. And this is a very important revolution that we need to immediately take also in the domain of the environmental monitoring. Becoming more and more important also to apply the Internet of Things revolution to green infrastructure. So we need to apply this concept of Nature 4.0 also to the management of our green systems in the urban environment. At least there are 2 reasons. One is because we need to create a better relationship of citizens with the nature, and having data streaming from the environment outside directly to the house, and let people look at the data and understanding what the trees are doing, what the soils are doing, what is the quality of the waters, the air, the wildlife tracking, for example. Sometimes it's possible to do that as well. It is really important for them to rebuild a good relation with nature. And the second reason is because managing green infrastructure is also a cost for the municipalities, and with accurate information, real-time information, is possible to prevent disasters, for example, or to manage better the success of green protections, or to predict and regulate, for example, impacts on the green urban areas. So that is a new frontier, and this is why it's now important to deploy these new technologies also at the level of the cities. For this aim, we have invented a new device that is called a TreeTalker. It's a small box that you can attach to a tree, and it gives continuously data on the tree health conditions, starting from measuring the water transport, so how much water the tree is taking up from the root system to the leaves in terms of liters per hour, or measuring the diameter growth. So how many millimeters is growing, and centimeters at the end of the season. The tree is growing in terms of biomass, so diameter growth is very important as a parameter also for measuring carbon sequestration, for example. And there is also quite fancy spectrometers that measure the light quality in 12 spectrometric bands. This allows to measure the change in leaf colors, for example, so you can detect anomalies in foliage that can be related to stress or to pathogens, or even you can follow the leaf development and how the trees respond in seasonality to different factors. So that's a complete system for assessing physiological parameters of the trees. In addition to that, there is also an interesting gyroscopic sensor that measures the position of the trees. That's very interesting. Why to measure the position of a tree? Trees doesn't move at all, but they oscillate, and they also change their position from their equilibrium. And this is a clear signal that they are maybe possible to fall down and create problems. As we have seen in many big cities today, the tree falling can have a huge impact on human lives, or also on infrastructure, on cars. And so it's possible to measure in this way fluctuations of the trees as an indicator of his their ability to fall down, or to see his changes from an average position. If there is a slow decline, a slow change, it's possible to measure it and record and give some alarms. So all these measurements are packaged in one little box, and this is the TreeTalker. All the data are sent out to the cloud, to internet. This is the typical setup of a number of trees that can be in a network of maybe 20 to 40 trees per group, per cluster. They send data to a router. The router will relay the data to the cloud, so to internet, and it's possible to visualize the data through web applications, even smartphones, or in general it's possible to do more fancy things like big data analysis, big data analytics, and so in order to extract all the information that are related to physiology and his performances. All these systems, so it's also very useful for citizen science, because a citizen can immediately see in their phones and smartphones also individual tree performances, and if they are performing well or not, or if they have problems. This is an example of installation of TreeTalker on a tree. On the right side, with you can see also a battery pack with a small photovoltaic panel And on the left there is the router, that is a small box where there is, in this case, inside also a GPRS SIM card, and all the trees around are submitting data to the router, and from the router they go through internet using telephone lines. These are some examples of data, the water transport, for example. On the left panel, you see the stem humidity, because the probe of the TreeTalker measure also the stem humidity alone. This is the diurnal trend. And on the right side, there is the sap velocity, so the flow of water inside the trunk. This is an example of radial growth measurements, and the system is a contactless sensor that has been taken by the robotic, let's say, technology to measure the diameter growth with a resolution of 200 microns. That is quite enough for detecting the seasonal change in the diameter growth. These are just some data, technical data about the spectrometry of the system, and for the people, the freak people interested in technology, this device has two spectrometers that measure 6 bands each, going from the blue color to the near infrared. And so in total there are 12 spectral bands, and they have been calibrated against a professional spectrometer in the laboratory, and you can see that calibrations in the bottom panel are really very, very nice, and the system is performing well at a really very low cost. That's the most important part of this device, that everything is very cheap to some extent. This is an example of time series of water transport, the blue line during several days, and on top there is the red line, the air temperature, and you can see how the trees are following very much the environmental changes, diurnal changes, but also there are periods where temperature, for example, is lower and transpiration is lower. So this is a real-time monitoring of the water transport, in this case expressed with liters per hour from this particular walnut tree. And it is possible so to monitor their performances in time. Another interesting feature of the TreeTalker is the possibility to measure the stability. So with this gyroscope inside, it's possible to detect oscillations, tree inclination. You can see from this graph an example of some oscillations of trees that have been detected during a wind, particularly strong wind event. The accuracy of the inclination measurements are at the level of 1/100 of degree, so it's really very, very precise, and can tell us the risk that the tree could fall down in the future. We're still working on the algorithms that are able to show this, but there are very good data coming now from several experiments in Moscow and in Rome. We have created a device that is really quite inexpensive. Each of the device costs in the order of $300, and it's possible to deploy a massive number of these sensors monitoring individual trees everywhere in the world. And we have a goal, actually, our vision as a collective community so far is to create the first TreeTalker urban global network. So using this technology in several capitals and cities all over the world, and monitoring simultaneously information about how trees respond to urban environment, how they are performing and providing their services. Of course, this is very, very open to also to citizens, to people interested. So it's not only science, but it's I think I strongly believe that it should grow also from the people that are interested to monitor their own tree in the garden or near the house. So there is a great potentiality for grow all together and create a big citizen science network all over the world. And we are targeting the 2019 to reach the 10,000 trees continuously monitored in the world. So far we are at about 600, so it's still long to go, but we have 1 year, and a lot of young people is working, and I think I'm very positive to say that we will grow up to that level. And of course this is an open call to everybody to join us in this very interesting new challenge. Okay, so thanks again for your attention, and I hope to have you on board. Anyway, any information you can take from writing to this email, info@nature4.org, and we'll keep in touch. Thank you.